Okay, so we're looking at areas under trigonometry, under trig curves, and it's a continuation of trigonometry and going back to the calculus or integration that you've been doing this year. Okay, so if I want to get an area under, for instance, y equals sine theta from 0 to x, okay, so 0 is back here. Okay, so if I want to get the area across to x, I've got one area here and I've got another area here. And if we just integrate from 0 to x, we're not going to get the right answer because some of the negative area in A2 is going to cancel out with some of the positive area in number 1. Okay, so we need to calculate this critical point just here where the areas change from positives to negatives or vice versa. Okay, so we're going to use our knowledge of sine and cos. We won't be doing tan. Okay, so first example, y equals 2 sine x. You've got to know what the sine curve looks like, and obviously it continues on and on and on to infinity and also backwards as well. Okay, so first thing you need to know is that number there is the amplitude. In terms of doing a sketch, you don't have to know it for the calculus. Okay, so that number goes there. And sine x, there's a coefficient of 1, so the period is 2 pi on 1, which is 2 pi. Which means that it'll cycle itself every 2 pi, and then halfway along is pi, and halfway along is pi on 2, and halfway along here is 3 pi on 2. So that's just by symmetry. Half along is half of the period, so half of 2 pi is pi. Halfway along for the maximum is half of pi, which is pi on 2. And if you add pi on 2 and pi, you'll get 3 pi on 2 for the third point. So in this particular case, if I'm going from 0 to 2 pi on 3, 2 pi on 3 is less than pi, so I am in this for the, sort of the first loop. So the area is all positive, so we don't have to break it up into smaller areas. Okay, so I set up my area integration. I don't have to worry about breaking up. So the area is the integral from 0 to 2 pi on 3 of the function with respect to the variable x. First thing is I always get to bring out the number 2. Now, just a reminder, when you derive, sine goes to cos, cos goes to minus sine. So if I'm integrating positive sine, I must have had negative cos back as the starting spot. So minus cos x. Now, if you want to, you can take the minus out, but I'm going to leave the minus in. Okay. So I put in minus is just straight, minus comes down, cos 2 pi on 3, then I subtract minus cos of 0. Now this number here, all stations to central. So I'm in this quadrant here because I'm past pi on 2. So cos is going to be a negative number in that second quadrant. And then in the second quadrant, the formula is pi minus theta. So if pi minus theta, so if pi minus theta equals 2 pi on 3, then pi on 3 must be the number that you've subtracted. And for cos, the answer is a half. Okay, so it's going to be minus a half, but it's minus sign from the formula, and then minus a minus is a plus, and cos of 0 is 1. Not forgetting that cos is on this axis, and so cos of 0 is cos at its maximum, which is 1. So you end up with plus, minus and minus is a plus, so a half plus 1 is 1.5, and 2 times 1.5 is 3. You're measuring area, so you must finish with units squared. If you forget the units squared, it's a half mark mistake once for the whole paper. Okay, copy that down, and when you're ready, come across. Okay, so next one is finding the area under 3 cos 2x between 0 and 5 pi on 4. So first thing you do is calculate the period. So that number 2 comes to the bottom, so 2 pi on 2 is just pi. Cos starts at its maximum, and the maximum is 3. Okay, and technically, if you want to, it goes down to minus 3, of course. Same with the previous one, it goes from, previous curve goes from 2 to minus 2. Okay, so pi is when it gets back to its starting spot, and so halfway is pi on 2, and then half of pi on 2 is pi on 4, and pi on 2 plus pi on 2 plus pi on 4 is 3 pi on 4. Pi plus pi on 4 is 5 pi on 4. So what you've got is 3 areas. You've got 2 positives and 1 negative. And you could break it up. If you wanted to, you could break it up into A1, A2, and A3 and add those areas up. But hopefully you can see that there's some symmetry, okay? And in fact that the total area is just going to be 5 lots of the first area, because you've got a quarter, like this is like a half, there's another half, there's another half, so you end up with 5 of those half areas. So it's going to be 5 times the area from 0 to pi and 4, which is going to be much, much, much quicker to do than to do 3 areas. So first thing I do is 5 times the area, and the integral is 3. So first thing you do is bring the 3 out, so you've got a 15 out the front. Now again, I always write sine goes to cos when you're deriving, cos goes to minus sine. So if I've got cos and I'm integrating, I must go back to sine. So cos 2x becomes sine 2x, but then you have to divide by the derivative of the function, so that's divided by 2. Then that 2 can come out. So now we've got 15 on 2. And then 2 times x, when I've got pi on 4, 2 pi on 4s is pi on 2, and 2 zeros is 0, and sine of pi on 2, okay, so sine's going up this way, so at pi on 2, sine's at its maximum, sine of 90 equals 1, sine of 0, at 0 sine is in the middle, so it's at 0, 1 minus 0 is 1, so you end up with 15 on 2 units squared. So again, this one is a quick way or a slow way. Quick way is look for symmetry wherever you can and shorten up your calculations. Copy, and when you're ready, come across. Okay, so in summary, you must sketch. If you don't sketch, you don't know, what is area above and area below. You just don't know until you do a sketch. Put in the x-intercepts, because that helps you find those things above and below. Work out which are positive, which are negative areas. Now, calculate the area separately, but, this is the but, or look for some symmetry if you can to make less calculations. Okay? So copy that down. So, like for instance, even though this one is a really odd one because it's not the whole way across, these two areas, A1 and A2, they're going to be the same as each other, so it would be easier to do a calculation from 0 to whatever that number is and then double it, and then worry about this calculation to here as just one other calculation. So you should always try to use a calculation that goes from 0 to something, because 0 is the easiest number to sub in. Okay, so hopefully you got something out of that, and we'll see you